as a solution to get to Mars in 40 days. And that's simply a lie. This is not possible with today's technology. And saying that is very bad because it is a means for the space agency to defer the decision to go to Mars, because they say, let us develop this wonderful engine and we can be on Mars in 40 days only. So they are excused to defer the decision to go to Mars. And to the public, it is a rather different situation, because on one end, it makes the image of the travel to Mars more sexy, more affordable. It said to have 6 months travel, you have only 40 days. It's good. So it's a positive side of this affair. I think it is always very bad to lie to the people. Remember the ISS situation. At the beginning, it was sold as a fantastic shop where miraculous materials or miraculous medicines would be produced, and in the end, we see nothing. So the public is very conscious of that, and the general impression is that the science and space people have lied to them and sold something which is funny thing. And my opinion is that we should be very careful not to do that again. And so, yes, the Vasimr concept is an interesting concept, and probably it's wise to put resources to develop the research on this topic, but on two conditions. First, that in parallel we put money to develop a nuclear electric generator light enough to be able to serve such an engine, and the second one is that we tell the truth to the public.
Next is Jeff Landis.
Oh, I'm sorry. Preview didn't hide.
It's okay. You should just be able to double-click the.
Yes. No. Now, let's pretend.
Is there any reason to have just double-click this one?
I do have that one
We have a
going.
hand.
This preview has got itself hung up. Oh, here you are. Okay. Now can you control PowerPoint? Okay, you're good to go.
Oh, good morning. I'm Jeff Landis. I'm with the NASA Glenn Research Center, which in fact for many years had been the NASA center that works on advanced propulsion. Actually, I should apologize for the slide. I grabbed some slides from an old lecture that I did on advanced propulsion for space at MIT, just because they had some good pictures, and I wanted to show some very good pictures while I was talking. I think maybe we should back up a little bit and talk about what is Vasimr and why Vasimr might be a good thing and why it might be a bad thing. Vasimr, in fact, is an acronym that stands for Variable Specific Impulse Magnetoplasma Rocket. But Vasimr is just one of many different concepts for how you might do electric propulsion in space. And I'm showing you, electric propulsion is real. We do this in space. There's real hardware. It has flown in space. In fact, back in the late 1940s and early 1950s, Wernher von Braun told his chief engineer, Ernst Stuhlinger, well, you should make a rocket engine that works on electricity, because this could be very efficient. We can get more efficiency than a chemical engine. And Stuhlinger later told the world, well, I thought that this was a crazy idea, but it turned out, I was thinking about it, and every other idea that Werner von Braun had turned out to be a pretty good one. So I said, well, I'll go through and work on this idea, even though I don't think it's a good idea. So he worked on it. He demonstrated an early electric engine, an ion engine. He then said, well, okay, we have a proof of concept. It's very inefficient. And he gave it to the NASA Lewis Research Center, now called the NASA Glenn Research Center, and said, okay, you guys figure out how to make this practical. And a guy named Kaufman went on to develop the Kaufman ion thruster, which was the first ion engines. These first ion engines were tested in a test called Solar Electric Rocket Test in 1964. And it tried some, actually it had 2 different ion engines on it. And actually only one of them worked. They had 50% efficiency on the function. One of them worked, one of them didn't. But the one of them worked showed that yes, the concept does work. We can get thrust in space. The particularly question that they needed a space test to answer was, would the neutralizer on this engine work? So the ion engine, in fact, works by pushing, I want this to go to the next slide. There it goes. The ion engine works by ionizing a gas. In fact, they started with mercury. And then once you have these ions, you can accelerate the ion across an electric field that pushes the mercury out the back. What's a rocket? A rocket's something that you push mass out this way, makes you fly out that direction. Well, the tricky part with the ion engine is these are ions going out, so it's charging up the spacecraft. Every ion you push out this way adds some electric charge to the spacecraft. So part of the ion engine development was a neutralizer that shoots electrons out at the same rate. They needed to make sure that this worked. It did, in fact, work fine, and ion engines have been working in space. After the 1964 test, they were tested again in 1970, and then there was a huge gap. They developed these ion engines, they worked, but nobody actually wanted to fly them on a mission. Everybody said, well, they'd be very efficient, but somebody else ought to fly it first. I don't want to be the first one. So, in fact, the Deep Space One mission in 1998 was the first mission to actually use ion engines for a demonstration mission. It flew by a comet, Comet Borrelli, I believe, and also by a little asteroid, asteroid Braille, just to demonstrate that ion propulsion does work. In fact, since then, we have the next ion engine. I think I just showed a picture of this. We've been testing this in our vacuum chamber at NASA Glenn. It has now been running for 30,000 hours continuously, 3.5 years. When the Deep Space One went in space, I think it had thrusted for as long as all of the other engines in space had been used. Well, you might ask the question, okay, well, this is great, but why? Why use any sort of electropropulsion? What's wrong with chemical rockets? Well, this is a parameter. The previous speakers mentioned something called ISP. How many of you know what ISP is? Let's see how many rocket scientists are here. Okay, about 2/3 of you know what ISP is. Okay, very good. For the 1/3 of you who don't know, ISP stands for specific impulse. It's a capital I for impulse, little sp, specific. What this means is how much thrust you get per unit mass flow of propellant. And the mass flow of propellant is actually measured in weight units, so it oddly comes out in units of seconds. This is actually equivalent to the exhaust velocity, because the faster you throw your propellant out, the more momentum you get out of a unit of propellant. Okay. Well, chemical rocket propellant uses the same, maybe that's a little bit too much. Chemical propellant uses the same mass that you're throwing out as your energy source. So you're limited by the amount of energy in the chemical energy. This gives you a maximum specific impulse of about 500 seconds. That is, you can have 1 pound of thrust on an engine, and it will run through 1 pound of fuel in 500 seconds. You'd like to get more out of it. And the only way to do that is have some other energy source. Unfortunately, so that's the good